In this case, one of the Volvos is parked. It's not moving. The other Volvo is going at the 60 miles an hour, 30 meters per second, and rams into it. And in the process, locks bumpers such that the two are moving together. Now, right after the collision, how fast are they going? Now, don't wait for them to scrape across the nose. Right after the collision, how fast are they going? Tell your neighbor. How fast? Thank you. Well, in the interest of time, let's do this together. P initial equals P final. Before the collision, I have 1,200 kilograms moving at 30 meters per second to the right, so it's positive. I also have 1,200 kilograms not moving at all. I just wasted ink. Afterwards, I have the two moving together, so that's 2,400 kilograms moving at some V final. That V final has to be 15 meters per second. I doubled the amount of mass that was moving. I have to cut the velocity in half. Now, folks, is the final kinetic energy 0? With your clicker one more time. What flavor of collision would this be? Okay? I gotcha. The answer is C, maximally inelastic. Now here, folks, I know you want to go out your weekend. I got 30 seconds. Maximally inelastic is when they lock bumper, period. They can still be moving. Maximally inelastic doesn't mean they have to lose all the kinetic energy. They just have to lose the most that's allowed by law. Newton's third law does not allow these cars to be stopped after this collision. It would violate Newton's third law. So maximally elastic just means lose the most. And that always happens when they lock bumpers. Have a great weekend, people. We'll see you on Monday.